This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss some technology solutions and problem extensions for the 2018 AP Calculus exam free response question AB6. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. And I'll focus on or I'll highlight the solutions presented in these guidelines, not how the points were awarded. Now, this question was not calculator active. However, I'll show you how to use technology to explore and answer parts of this question and to confirm solutions where it's appropriate. And because the free response questions are usually very comprehensive, I'll suggest some problem extensions, additional AP Calculus type questions associated with the information given in the problem. And some of these questions may be calculator active. In this free response question, we're given a differential equation in terms of x and y. In part A, we are presented with the slope field that corresponds to this differential equation. And we need to sketch two solution curves, one through the point 0, 2, and another through the point 1, 0. In part B, we assume that y equal f of x is a solution to the differential equation with initial condition f of 1 equals 0. We need to write an equation for the line tangent to the graph of y equal f of x at x equal 1. And then we need to use this equation to approximate f of 0.7. In part C, we need to solve the differential equation. That is, we need to find the particular solution to the differential equation with initial condition f of 1 equals 0. Part A was worth 2 points. Very simply, 1 point for sketching the solution curve through the point 0, 2, and 1 point for sketching the solution curve through the point 1, 0. Part B was also worth 2 points. 1 point for writing an equation of the tangent line to the graph of y equal f of x at x equal 1, and 1 point for using this equation to approximate f of 0.7. Part C was worth 5 points. These points were earned, or partial credit was awarded, along the way to solving this differential equation using the method of separation of variables. The first point was for separating the variables. The next 2 points were for the antiderivatives, 1 point for each side. The fourth point was for introducing a constant of integration correctly and for using the initial condition. And the last point was for putting everything together and solving for y. In part A, when sketching these solution curves by hand, each solution curve must go through the indicated point. It must follow the given slope field line segments, and it must extend to the boundary of the slope field. Now, it takes some practice to sketch these curves in a smooth, continuous manner. However, we can use technology to quickly and accurately sketch these solution curves. Using the TI-Nspire, we can enter a differential equation with an initial condition, well, actually several initial conditions, and produce the slope field and the solution curves. And we can also make the graph appear smoother by selecting a smaller plot step. Here's a solution to part A using technology. This example is an extension to this free response question. First, sketch the slope field in a little different window. And then sketch the solution curve that passes through the point 0, 5. And finally, consider any solution curve that passes through the point AB, for example, where B is not equal to 2. Explain why this solution curve cannot pass the line y equal 2. In part B, we need an equation of the tangent line through the point 1, 0. To find the slope, we use the expression given for dy dx. Then use the point-slope form to find an equation for the tangent line through 1, 0 with slope 4/3. Now this equation is a reasonable estimate of the function f near x equal 1. So we can use this equation to estimate f of 0.7, and the estimate here is minus 0.4. Although probably not necessary, we can use technology to solve this problem. On a calculator page, I first found the slope, and then I defined an equation of the tangent line. And finally, I evaluated the tangent line equation at 0.7. Now, we can also visualize this result on a graphs page. Here, I drew the tangent line on the same coordinate axes with the slope field and the solution curve. And we can see how the tangent line is a reasonable approximation near x equal 1. And we can also produce the approximation on this page. In Part C, we need to find the particular solution to the differential equation with initial condition f of 1 equals 0. Now, without technology, we would use the method of separation of variables. However, the TI-Nspire has a built-in function to solve a differential equation. The function DE_solve can be used to produce a particular solution to a DE. The input arguments are pretty natural, and this even produces the solution in the same form as given on the scoring guidelines. That's pretty cool. Here's another example for you to try related to the differential equation given in this free response question. In Part A, let's suppose that y equal f of x is the particular solution to the differential equation with initial condition f of 2 equals 1. Write an equation for the tangent line to the graph of y equal f of x at x equal 2, and then use this equation to approximate f of 0.5. In Part B, determine whether the approximation in Part A is an overestimate or an underestimate. In Part C, find the particular solution to the differential equation with initial condition f of 2 equal 1. And finally, use the solution, the particular solution in Part C, to confirm your overestimate or underestimate answer in Part B. And here's one final problem for you to try. It involves a slope field and a particular solution to a differential equation. So we're given the slope field associated with the differential equation. First, sketch the graph of the solution curve through each point. So in Part A, I'm looking for 3 distinct solution curves. And in Part B, write an equation for the tangent line to the graph of y equal f of x at x equal 1. I hope this video gives you some good ideas for additional practice AP Calculus type exam questions and of how to use technology to solve some of the parts of this problem and to explore, confirm, and visualize results. This problem presents some good opportunities to discuss slope fields, solution curves, and separation of variables as a technique for solving a differential equation. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.